So that was a very high-level look at some of the requirements coming from the mobile world. Now we're going to look at what the ITU are doing, the standards bit, how they're trying to support those requirements and provide those services, or provide support for those services, sorry. So the ITU has been working on standards from study group 15, question 13, the study group that looks specifically at network synchronization in terms of wide area telecom networks, and they've published a whole series of standards. It started in 2006 with 8261. That was the first of the so-called next generation sync or packet or sync over packet standards that was released in 2006. But as you'll see, there's a whole series of standards. This is, again, this is a slide that's taken from a presentation by Jean-Loup Ferrand that was done at WSTS as an overview of where the ITU are at. So the ones in green are agreed and approved. The work at the moment is going on in this side. So they decided to split the standards into a 60 series and a 70 series. So 82.60 something and 82.70 something. This is purely to do with frequency distribution. So this is frequency over packet, so PTP delivering frequency. The work at the moment is all going on in this part of those recommendations, 8270 series, where we're talking about time and phase distribution, specifying things like the PRTC, the primary reference time clock, the performance of grandmasters, boundary clocks, and transparent clocks. These are all entities that live within 1588. And then the profiles I mentioned earlier, 8275.1, which is with full on-path support for PTP, and 8275.2, which is the partial on-path support. So that's where the work is ongoing at the moment. 8272, I think Steve had this in his jargon buster. This is taken straight from 8272. It talks about the PRTC, and getting back to some of the points I was trying to make in the first slides, was we're still using that frequency stability. We're using it as an assist. We saw earlier, we heard discussion about synchronous Ethernet used as assistance to PTP or assistance to GPS receivers. And this is really taking time reference signal, for example, from GPS and ensembling that information and then producing frequency and time and phase to distribute throughout the network. So this is a functional model of that PRTC. 8275, the standard, talks about architecture, talks about network architecture. So this, again, is a very, very high-level diagram of some sort of master clock that has a reference, a UTC-based reference, like we talked about before, and transports those packet timing signals over a network to slave clocks. So these slave clocks, you can assume these are either embedded within a base station or they are within one of those cell site gateway type boxes. And they are providing the frequency and the time and the phase synchronization to those applications. So the applications at the edge of the network classically are those wireless base stations that are using those LTA techniques. So the last ITU meeting was the second week in April. It was in San Jose in California, where 8275 and 8275.1 and .2, the two profiles for time and phase, were discussed. This is as it stands at the moment. So this is from the draft from that April meeting. So it's specifying full on-path support. So to meet this profile, you'd have to have every node PTP aware. Now, at the moment, it's talking about boundary clocks. So that's a boundary clock in every node. Could include transparent clock in the future. It doesn't rule it out. And it's also talking about synchronous Ethernet. So going back to the PRTC idea, you have a frequency reference from that underlying physical layer. This profile defines the telecom grandmaster and the telecom time slave clock. So these are things that the profile is allowed to do. So 1588 as a standard, as we talked about earlier, really only tells you how to get time over a network. It's very, very abstract. It doesn't necessarily define, doesn't tie you down to lots of things, but it allows each use case, each industry, of which obviously telecom is one, to define their own profile, to define a subset of all the things that the IEEE allow within 1588. And one of those things that they allow is master clock entities, network node entities like this, which types of communication are allowed. So this full on-path support profile talks about two-way only. And lots of discussions in the standards group, as ever, trying to catch up with what's happened in the real world. There have been lots of deployments of 1588 in Asia that have used what's called a default profile. So they have a specific domain number, they use specific multicast addresses, and although it may not be applicable to telecom at this point, they wouldn't necessarily have chosen them. There's obviously a lot of weight to the argument to support those existing deployments. So the discussion, lots of discussion in the ITU was over which domain number to use, which was about as exciting as it gets in the standards group. Should it be 0 or should it be one of the reserved numbers that telecom is allowed to use? But that's still undecided. So that's where the full on-path support profile is at the moment. The telecom profile for partial on-path support has not really progressed very much because the focus has been on 827.5.1. So the North American carriers were pushing for focus on the full on-path support profile. But partial on-path support implies that you have some network that doesn't have any transparent clock, boundary clock in it. You have boundary clocks at intervals. So that's still under discussion. And then getting towards the last slides in this deck, Billy mentioned this. So study group 15, question 13 is that part of the ITU that deals with synchronization. They've gone away and asked question 2 and question 9, which are different parts of the ITU that look at some of the physical layer technologies and some of the other technologies, specifically DSL and PON. So question 13 has said, we know we've got upcoming requirements to support mobile operators with LTE advanced services that are going to be asking for sub-microsecond phase alignment at the edge of the network. Is there anything that we can do? Is there anything that's already there within PON and DSL specifically that can help us get phase out to the edge of the network? And the brief discussions that happened, it turns out, yes, there is. So DSL has always had within it so the ATUC is the central office part of the DSL modem. The ATUR is the remote end, so that's the subscriber end. Has always had an 8 kilohertz reference clock, this NTR, network timing reference, that's within the system, but it's never been passed out to the user. It's never been used. I think some vendors have had proprietary systems where they could effectively use it to carry E1s over DSL. But it's not much of a step forward to be able to then apply phase markers to some of these 8 kilohertz subframes and get phase to the edge of the network. Similarly with PON. So passive optical networks have passive optical splitters in this direction, and then all the end units are allowed to transmit in a time slot. So for them to do that and for the data to arrive in the right time slot, this technique called modem ranging happens, where effectively the distance between these things is measured, so they very accurately can then time the replies to arrive in the right time slots. So yes, PON has support as well for modem ranging. And again, it's not much of a step forward to be able to get phase alignment from PON systems. But the thing is, the two questions at the bottom, when will this change happen? This is only preliminary discussions in the ITU at the moment. And is it going to be for greenfield use? Is it going to be something that can be rolled out with firmware, software changes, or is it going to need new hardware? That's something that's still under discussion. So there may be assistance, there may be further assistance from the underlying network technologies to help us get phase and time to the edge of the network. I think this is the last slide. Hybrid techniques and ensembling. This is something that's becoming more and more prevalent in when I first started working for Chronos in 2006, and I went to the WSTS conference in North America, it was almost a religious battle, or a sort of religious fervor between different sync technologies. There was SyncE and there was 1588, and the 1588 supporters said that 1588 would solve all your network operators' needs. The SyncE supporters said the same. But I think over the years there's become a realization that these technologies can work together, and as well, using what we already have, using GPS, using the cesium stability that we already have. And now again, this last diagram here is taken from 8272, and you can see it talks about the core network having a physical layer, having a frequency distribution. So the blue circle here with a sine wave in it is frequency distribution, and then these red circles with sort of clock hands in, they signify the time distribution. So it's more and more vendors are now using this idea and ensembling what they've got. So I think that's what we will see eventually support small cells to the edge of the network. GPS wherever you can, wherever it makes sense, 1588, synchronous Ethernet, physical layer support to make sure that we meet those requirements 100% of the time. So thank you very much. That's the end of my presentation.